Imagine a world built by invisible hands. A world where metal heals itself, where airplanes refuse to corrode, where medicine travels through your bloodstream like guided rockets, and all of it begins with building blocks smaller than a virus. That world isn't coming. It's already here. It's called the nanotech revolution, and it's quietly rewriting the rules of materials, manufacturing, and medicine one atom at a time. Look around. Your phone battery, that self-cleaning window, even the vaccine that saved millions of lives. They've all been touched by technology operating at a scale too small for the human eye to see. We're no longer just shaping materials. We're reorganizing matter itself, engineering reality from the ground up. To grasp that shift, picture this. A single nanometer is 1/1,000,000th of a meter. A sheet of paper is 100,000 nanometers thick. At that scale, quantum physics, not classical rules, starts to dominate. Atoms shimmer with new possibilities. Metals turn to catalysts. Light bends around engineered particles, and matter begins to obey design instead of chance. It's a transformation so fundamental it's been compared to mastering fire or electricity. Except this time, the forge exists inside the atom. So how did humanity go from raw materials to rewriting matter itself? And what does this invisible revolution mean for the future of energy, medicine, and technology you'll use tomorrow? The dream of manipulating matter atom by atom didn't begin in the 21st century. It began in 1959 with a young physicist who loved big questions. Richard Feynman stood before an audience at Caltech and asked, "What if we could arrange atoms one by one, just the way we want them?" It sounded poetic then. Today, it's practical engineering. For decades, that vision sat out of reach. Scientists could see molecules but not move them. Then the scanning, tunneling microscope changed everything. For the first time, we could touch individual atoms and push them around. From that moment, nanotechnology began its long crawl from speculative philosophy to manufacturing reality. Fast forward to now, we've entered a perfect storm of converging technologies. Artificial intelligence designs new materials before they exist. Quantum-level simulations predict properties that used to take years of trial and error. And fabrication tools, like atomic layer deposition and laser-driven 3D printing, can replicate laboratory miracles at an industrial scale. Together, these forces have turned someday into supply chains. The same principles that power the world's smallest transistors also drive cancer-targeting nanoparticles and next-gen aerospace composites. Economies are being rebuilt quietly, molecule by molecule. The paradox? This revolution is unfolding mostly out of sight. There are no smokestacks, no glowing reactors, just silent atomic foundries on silicon wafers and inside biolabs. Yet the implications are immense. Whoever controls nanoscale engineering will shape energy, medicine, computing, even the balance of global power. So what exactly is nanotechnology? And how does tweaking matter at billionth of a meter scales unlock physics that defy intuition? It's time to look closer, much closer. At its core, nanotechnology is the art of controlling matter between 1 and 100 nanometers, a frontier where quantum mechanics rules, surfaces dominate, and ordinary materials behave in extraordinary ways. This isn't simply shrinking devices until they're tiny. It's designing new rules for nature. When we say nanotech materials, we're talking about a family so diverse it spans electronics, healthcare, energy, and construction, each built from atoms placed with intention. Start with nanomaterials like graphene, a one-atom thick sheet of carbon stronger than steel, yet transparent and flexible. Or quantum dots, tiny semiconductor crystals that glow in purer, brighter colors than any conventional pigment, turning modern TV screens into living light. Then there are carbon nanotubes, cylinders so strong that aerospace engineers dream of building aircraft skins and space structures from them. These materials act differently not because of what they're made of, but because of their size. Next come nanodevices, machines and sensors operating where biology and physics blur. Imagine molecular switches inside computer chips that move single electrons or nanobiosensors capable of detecting a disease marker in a single drop of blood. In healthcare, nanomedicine delivers cancer drugs directly to tumor cells with pinpoint precision. The treatment travels like a guided missile, leaving healthy cells untouched. And finally, the field that ties it all together, nanofabrication. We now print, deposit, and grow matter one atomic layer at a time. Think inkjet printing, except the ink is molecules and the printer writes the future. But here's the catch. Nanotechnology is not sci-fi nanobots swarming in your veins or machines replicating themselves in secret. It's subtler, safer, and far more human. A toolkit for engineering everything better, smaller, cleaner, and smarter. Still, its results verge on the magical. Because when you play Lego with atoms, you redefine what's physically possible. Next comes a proof. Fields already transformed by nanoscale design. Now the invisible revolution becomes visible. Energy first. Tiny quantum dots are breaking physics, so-called speed limit, absorbing parts of sunlight traditional silicon can't touch. They convert one photon into multiple energized electrons, turning rooftops and even windows into power generators. Printing these photovoltaic films can make solar energy cheaper than coal and flexible enough to coat cars or clothing. Storage next. Nanostructured batteries trade graphite for antimony nanochains or tin nanoparticles small enough to slip between atomic layers. They charge in minutes, last longer, and pack 50% more energy into the same footprint. That's not a tweak. It's the difference between anxiety over range and forgetting range even exists. Medicine follows. Instead of flooding the body with chemotherapy, nanocarriers act like precision drones, circulating harmlessly until they meet their molecular target, releasing drugs only where they're needed. Billions of lipid nanoparticles in COVID-19 vaccines have already proved Nanotech can scale safely to humankind. Now, the same principles are rewiring everything from gene therapy to early disease detection. And electronics? We've officially reached the frontier where silicon stumbles and materials a few atoms thick take over. Graphene and molybdenum disulfide transistors are being printed onto flexible plastic, whisper-thin circuits that bend like paper and process data faster than anything we've known. The next generation of quantum dots and atomic memories blurs the line between computing and cognition itself. What connects them all is a shared idea. By shrinking down to the nanoscale, we unlock performance and possibilities that macro-scale science never offered. Yet, as the power to reconstruct matter itself scales up, a new question emerges. Who controls this microscopic forge? That question leads us from the labs to the world stage, where nanotech is already redrawing maps of innovation and power. The nanotech revolution is quiet, but unstoppable. It doesn't roar like rockets or glow like fusion. It hums in laboratories, in clean rooms, and even in your pocket. Every smartphone screen that radiates richer color, every lightweight solar panel, and every targeted therapy molecule is a signature of this invisible engineering. For the first time in history, humans can reshape the physical world with atomic precision. We can decide how light bends, how metal heals, and how cells respond to disease. By design, not chance. That's the true miracle. We've moved from using materials to writing them. But power this small has consequences this large. Who governs the invisible factories of the 21st century? How do we balance infinite innovation with safety, equity, and ethics when atoms are the new frontier? The race to master matter is already geopolitical, economic, and profoundly human. And while it feels futuristic, it's becoming everyday life. From nanostructured batteries that outlive cars to self-cleaning buildings and programmable fabrics, the design of matter is merging with the design of society. It's not just manufacturing, it's remanufacturing reality. So as we close this episode, one truth stands clear. This revolution can't be seen with the naked eye, yet its fingerprints cover everything. Stay curious, because the next wave is even smaller and infinitely larger. In our next Future Forge Explored episode, we'll dive into self-healing materials, how polymers modeled on living tissue could make collapse and corrosion things of the past. The age of atomic craftsmanship is here, quiet, precise, and world-changing. And it's only just beginning.